Assalamualaikum warahmatullahi wabarakatuh. Today we are going to learn a new topic, which is redox equilibrium. There are 6 subtopics in this chapter, which is oxidation and reduction introduction, standard electrode potential, voltaic cells, electrolytic cells, extractions of metals from ores, and the last one is rusting. In the first subtopic of redox equilibrium, we will discuss about introductions on how does oxidation and reduction occur. It consists of oxygen, hydrogen, electrons, and oxidation number. So, the definitions of redox reactions is a chemical reactions where oxidations and reductions occur simultaneously. We know that redox comes from the words red, reductions, and ox comes from the oxidation reaction. Redox reactions can be explained using 4 terminology, which is the first one is gain or loss of oxygen. The second one is gain or loss of hydrogen. The third one is transfer of electrons, whether the substance receive or release electrons. And the last one is change in oxidation number, whether the substance the oxidation number of the elements increases or decreases during the reactions. Now, we will discuss on the first terminology, which is the gain or loss of oxygen. Just refer for this example. In this reaction, magnesium atoms before the reactions is Mg. After the reactions, magnesium atom gains oxygen and form magnesium oxide, while carbon dioxide, the formula is CO2. After the reactions, CO2 lose the oxygen and form carbon atom only. It is said to be magnesium gain of oxygen and undergoes oxidation, while carbon dioxide lose the oxygen or lost the oxygen and undergoes reduction reaction. The oxidized substance is magnesium because magnesium gains oxygen. The reduced substance is carbon dioxide because carbon dioxide loses oxygen. Carbon dioxide is the oxidizing agent because carbon dioxide helps magnesium undergoes oxidation, while magnesium is a reducing agent because magnesium helps carbon dioxide undergoes reduction. Both reactions, oxidation and reductions, occur simultaneously. That's why these reactions are considered as redox reactions. Now, let's carry out an activity. The first one, the reactions between copper oxide and carbon is an example of a redox reaction. Write a balanced chemical equations for the reactions that takes place. State the name of the reactions, whether copper oxide or carbon undergoes oxidation or reduction, and then identify the oxidized substance, reduced substance, oxidizing agent, and reducing agent. This is the balanced chemical equations for the reactions. We can see that copper oxide loses its oxygens and form copper atom, while carbon atoms gains oxygen to form carbon dioxide. Carbon undergoes oxidations, while copper oxide undergoes reductions. Now, write down the answer. Copper oxide undergoes reduction. Carbon undergoes oxidation because carbon gains oxygen. The oxidized substance is carbon, while the reduced substance is copper oxide. Oxidizing agents is opposite the reactions occur. Copper oxide is a reducing agent because copper oxide undergoes reduction, while the reducing agent is the substance that undergoes oxidation, which is carbon atom. So, for the first terminology, we can conclude that in oxidation, substance will gain oxygens, while in reduction reactions, substance will lose or lost its oxygen. If the reactions doesn't involve with oxygen, so we need another substance to be able to explain the redox reactions. The second terminology of redox is gain or loss of hydrogen. For this example, hydrogen sulfide will form sulfur, while chlorine molecule will form hydrogen chloride molecules. In this reaction, hydrogen sulfide loses its hydrogen, while chlorine will gain the hydrogens to form hydrogen chloride. What are the reactions occur in this experiment? When hydrogen sulfide lost its hydrogen, the reaction occur is oxidation, while when chlorine molecule receive hydrogen, the reactions that occur is reduction. It is said to be hydrogen sulfides undergoes oxidations because hydrogen sulfide loses its hydrogen, while chlorine molecules undergoes reductions because chlorine molecules gains hydrogen. Chlorine molecule is an oxidizing agent because chlorine helps hydrogen sulfides undergoes oxidation, while hydrogen sulfide is a reducing agent because hydrogen sulfides helps chlorine undergoes reduction. Now, let us do some activity about the gain and loss of hydrogen. Referring to this chemical equation, we have to identify which substance is oxidized, reduced, and which substance is oxidizing agent and reducing agent. This is the reactions occur during the reaction. Ammonia lost its hydrogen to form nitrogen molecules, while copper oxide gains the hydrogens to produce copper and water. So we can conclude that the losing of hydrogen is the oxidation reactions, while the receiving of electrons is the reduction reactions. Therefore, copper oxide undergoes reduction, while it's actually ammonia here. Ammonia undergoes oxidation. Okay. Which substance is oxidized? Ammonia is oxidized, while copper oxide is reduced. So from these two substances, which one is the oxidizing agent? Copper oxide is the oxidizing agent, while ammonia is the reducing agent. So it can be concluded that receive or gain of oxygen is oxidation reaction. The substance that lost oxygen undergoes reduction, while substance that lost hydrogen undergoes oxidation, while substance that gain hydrogen undergoes reduction. Now, we will discuss on the third terminology of redox, which is transfer of electrons. Referring to these chemical equations, magnesium atom reacts with oxygen molecules to form an ionic compound, which is magnesium oxide. We have learned that magnesium oxide is an ionic compound. ionic compound comes from or is a product when magnesium ion combine with oxide ion by strong electrostatic forces. Note that when the type of particles of substance changes, like these reactions, magnesium atom change to magnesium ions, while oxygen molecule change to oxide ion, there must be a transfer of electrons. Magnesium atom will release electrons in order to form magnesium ion. When magnesium atom release electrons, it undergoes oxidation reaction, while when oxygen molecules receive electrons, it will produce oxide ion. The process of gaining electron ensure that oxygen molecules undergoes reduction. This is the third terminology of redox. Referring to these reactions, we know that magnesium is the oxidized substance because magnesium atom loses electrons, while oxygen molecule is the reduced substance because oxygen molecules gains electrons. Oxygen molecule is an oxidizing agent because oxygen is the electron acceptor, while magnesium atom is a reducing agent because magnesium is an electron donor. Or we also can say that magnesium atom helps oxygen to undergo reduction. That's why magnesium is a reducing agent. Let us discuss the second example that occur in the transfer of electrons. The reaction is between zinc atom and hydrochloric acid. We know that hydrochloric acid must dissolve in water to form hydrogen ion and chloride ion in order to react with zinc atom. It will produce zinc chloride compound. Zinc chloride is an ionic compound, whereas zinc ions combine or attracted with 2 chloride ion by strong electrostatic forces. Another product of these reactions is hydrogen molecule. We can see that zinc atom changes to zinc ion. If you care enough, you can see the changes in type of particles means there are transfer of electrons. Another particles that change its type of particles is hydrogen ion. In the reactant side, hydrogen exists as an ion, but in the product side, hydrogen exists as the molecule. There must be a transfer of electrons involved, and for sure these reactions might be a redox reactions. Now, look at the half equation. Zinc atom release electrons. Therefore, it is said that zinc atom undergoes oxidation. While what happens to hydrogen ions? Hydrogen ions receive electrons. It is said that hydrogen ions undergoes reduction. Zinc is the oxidized substance because zinc atom loses electrons, while hydrogen ion is the reduced substance because hydrogen ions gains electrons. Hydrogen ion is an oxidizing agent because hydrogen ion is the electron acceptor, while zinc atom is a reducing agent because zinc atom is an electron donor. Now, let us conclude the three terminology of oxidation and reduction reaction. A substance is said to undergo oxidation when it receives or gains oxygen, while if the substance loses its oxygen, it is said to undergo reduction. If the substance releases or loses its hydrogen, it is said to undergo oxidation, while if the substance receives hydrogen, the substance undergoes reduction. And the last terminology, if the substance loses its electrons or releases its electrons, it is said that the substance undergoes oxidation, while if the substance receives electron, it is said that the substance undergoes reduction. Because transfer of electrons have significant effects on the oxidation number, so we will discuss the oxidation number, changing in oxidation number in this same experiment. Now look at this same experiment again. Zinc is an atom. The oxidation number of atom is 0. The oxidation number of regular ions is same with the charge of the ion. So hydrogen ion, the oxidation number is +1, while chloride ion, the oxidation number is -1. This oxidation number is the same as the charge of the ion. On the product side, zinc chloride is ionic compound. Therefore, the particles present in the compound is ion. Zinc ion is the regular or common ion. So the oxidation number of zinc is +2, while chloride is still -1. For the molecule that consists of same elements, the oxidation number is 0. Now, by looking at the changes in oxidation number, we can describe redox reaction. For zinc, the oxidation number changes from 0 to +2. Therefore, the oxidation number increases. While the oxidation number of hydrogen decreases from +1 to 0. So what happens to these two substances, zinc atom and hydrogen ions? Okay. When there are increase in oxidation number, the substance are said to undergo oxidation. But if the oxidation number decreases, the substance are said to undergo reduction. Therefore, zinc is the oxidized substance because oxidation number of zinc increases from 0 to +2, while hydrogen ion is a reduced substance because oxidation number of hydrogen decreases from +1 to 0. Hydrogen ion is an oxidizing agent because hydrogen ions helps zinc undergoes oxidation, while reducing agent is zinc atom because zinc atom helps hydrogen ion undergoes reduction. I can explain the change in oxidation number easily because I have been memorized the rules of oxidation number. We will see the rules of oxidation number later on in the next slide. Now, let us conclude all four terminology or description of redox reactions. For oxidation, if the substance gain oxygen or lose of hydrogen, lose of electrons, or increase in oxidation number, the substance are said to undergo oxidation. Remember, when substance release electrons, there must be changes in the oxidation number too. While if the substance loses oxygen, gain hydrogen, increase or receive of electron, and decrease in oxidation number, the substance are said to undergo reduction. When the substance receive electrons, there must be changes in oxidation number too. For me, I just remember both explanation or description or terminology by using this mnemonic. Reduction, tambahi, formula on. If we memorize one part of the reactions, we obviously can relate to the next reactions because it is oppositely matched. So please memorize this for terminology of redox. As I promised before, we will see and go through the rules of oxidation number in order to have more information about the oxidation number. What is actually oxidation number? Oxidation number is the charge of the elements in a compound if the transfer of electrons occur in an atom to form chemical bonds with other atoms. How do we know the oxidation number of elements? Yes, we need to memorize the rules of oxidation number. I've been summarized and simplify the rules for all of you. The first rules are oxidation number of all elements is 0. The example of elements are atoms, sodium atom, zinc atoms, oxygen molecules, which only consist of same type of elements: ozone, nitrogen, chlorine. So all oxidation number of the elements is 0. Next, rules number 2. Oxidation number of monoatomic ion is equal to the charge of the ion. What is monoatomic ion? Zinc ions. So the oxidation number of zinc ion is +2, equal to the charge. Sodium ion. Oxide ion. The oxidation number of oxygen in oxide ion is -2. Chloride ion. Oxidation number of chlorine in chloride ion is -1. Now we move to the rules number 3. Oxidation number of elements in its compound for group 1, 2, and group 13 is +1, +2, and +3. One example of these rules is aluminium oxide. So, in this compound, we cannot see the charge, but we know aluminium comes from group 13. Therefore, the oxidation number of aluminium is +3, while the oxidation number of oxygen, which is monoatomic ion, is -2. One more example is sodium chloride. We know that sodium situated in group 1, therefore the oxidation number of sodium is +1, while chlorine is -1. Can you get what I mean by oxidation number of elements in its compound? I hope you can understand. Now, can we move to the rules number 4? Sum of oxidation numbers of element in a compound is 0. Okay. what does it mean by these rules? Let's say we are calculating the oxidation number of magnesium oxide. So, the sum of the oxidation number, magnesium, the oxidation number is plus 2. How many magnesium? 1 plus the oxidation number of oxygen is negative 2. How many oxygen? 1. The total of this oxidation number must be 0. Am I right? Okay, one more example is oxidation number of aluminium oxide. Now, aluminium is plus 3. How many aluminium? 2. Total it with oxidation number of oxygen, negative 2. How many oxygen in the compound? 3. So the total of the compound, the total of the oxidation number must be 0 because the compound is neutral compound. Now let us see the fifth rule. The sum of oxidation numbers in polyatomic ion is equal to the charge of the ion. Let's say we are calculating the oxidation number of sulfur in sulfate ions. We never come across to the oxidation number of sulfur before. So, we change the oxidation number of sulfur into unknown X. X added with oxidation number of oxygen. How many oxygen in the ions? 4. So we need to multiply it with 4. The total oxidation number for these ions, it must be equal to the charge of the ions. Therefore, it is equal to negative 2. Can we calculate the oxidation number of sulfur? X is actually negative 2 plus 8 is positive 6. So the oxidation number of sulfur in sulfate ion is positive 6. The polyatomic ions means it consists more than one elements in the ions, such as nitric ions, manganate ion, dichromate ions. You will see, you will come across to these ions later on, inshallah. Now, the last rules of oxidation number is number 6. It is said that oxidation number of hydrogen is plus 1. Same with oxidation number of hydrogen in hydrochloric acid, except in metal hydride. Oxidation number of oxygen is negative 2 except in peroxide. So you will come across to this uncommon, okay, uncommon oxidation number later on. Now, let us do some exercises in calculating or determining the oxidation number of certain elements in a compound or a polyatomic ions. I will show you one example, but the rest of it, please complete it and send it to me into our Teams. Okay, so the first example is manganese in manganate ion. So in order to determine the oxidation number of manganese in this polyatomic ion, so I need to change the Mn into unknown X. How many manganese in the compound? Only one, so times it with 1. No need to write it. It's also correct. Okay. Next, the oxidation number of oxygen is -2. How many oxygen in the polyatomic ion? Is 4. Total it with the charge of the polyatomic ion, which is -1. So X is -1 plus 8. So X is plus 7. You need to write the plus symbol, the positive symbol, because this is oxidation number. Have you ever heard that this manganate ion is also called as potassium manganate 7 solution? So the symbol 7 here is actually the oxidation number of manganese in the manganate ion. Okay, if we write the chemical formula of potassium manganate 7 solution, it is KMnO4, potassium manganate solution. So for number 2, 3, 4, 5, 6, 7, and 8, you can always check for the rules in the last slide and show your calculation to me in Teams. Don't forget to do this, as this homework will be considered as your attendance for today's lesson. Thank you very much, and Assalamualaikum.